Welcome back to English BookCast. It's great to have you with us for another deep dive. If you're enjoying these explorations and getting something out of these deep dives, we would really love it if you could consider subscribing and sharing this with other people who you think might enjoy it too. Really helps us bring more of these dives to you.
It really does. The more the merrier, as they say.
Today we're going back in time, back to 1998, to a U.S. patent filed back then. And it outlines a system, a method really, for communication and even control using brain activity analysis. It's kind of wild to think that this was being explored way back then.
Oh, absolutely. I mean, think about it. A patent from 1998 talking about direct communication from our minds and even the potential to influence brain functions. Yeah, it really gets you thinking about what people were envisioning back then.
For sure. So our mission in this deep dive is to understand the core concepts of this patent, how it proposes to work, and to really see how this invention aimed to connect our internal thoughts with the outside world. Hopefully, we'll uncover some surprising insights along the way.
Well, let's hope so. The patent we're looking at is US Patent 6011991, and it's called Communication System and Method, including brainwave analysis and/or use of brain activity. Definitely some pretty ambitious ideas for its time.
Okay, so let's jump right in. What's the main idea, the fundamental concept this invention is based on?
Well, in a nutshell, the invention is about monitoring an individual's brain activity, then transmitting that information remotely, and this is key, potentially even using satellites, to another location where a computer system compares this brain data to a set of pre-recorded brain activity patterns specific to that individual. They call these normalized patterns.
Normalized brain activity, what's that all about? Sounds pretty important.
It is. Normalization is about creating a baseline, a kind of average representation of someone's brain activity for specific thoughts or intentions. The patent talks about a process where someone is asked various questions and their brain responses are recorded. It could be the same question asked repeatedly or different questions. The idea is to get enough data to establish a consistent pattern for, let's say, thinking yes versus thinking no, or even trying to communicate specific words or phrases.
So it's like creating a personalized dictionary of my brain activity, like a map of my thoughts.
Exactly. And once you have this dictionary of normalized patterns for someone, the system can take their real-time brain activity and compare it to see if it matches any of those stored patterns. And from that, the computer can figure out what they're trying to communicate.
Fascinating. And you mentioned transmitting this remotely, even via satellite. How do they envision that working?
So the patent outlines a system with sensors, maybe even implanted sensors, to monitor brain activity. This data then feeds into a transmitter, which again could be implanted. This transmitter then sends a wireless signal, and the patent specifically talks about radio frequency signals and using satellites up to a satellite.
So the satellite acts like a relay station in space.
Precisely. The satellite receives this signal and retransmits it down to a receiver somewhere else on Earth. Then, this receiver takes that raw brain activity data and feeds it to a computer for analysis. And that's where the comparison with the individual's library of normalized patterns comes in. It even mentions communication between Europe and the US as an example, highlighting the potential for global thought-based communication.
Wow, that's a pretty big vision. Let's go back to normalized brain activity for a moment. How would you create those personalized baselines?
So this is fundamental, and the patent details a way to create a unique database of brain activity for each person. This involves presenting someone with specific stimuli, asking questions, for example, and meticulously recording their brain activity as they respond. The patent emphasizes that these recordings, for the same intended response, would be normalized or averaged.
So if the system needs to know what my brain activity looks like when I think hello, it would record my brain activity multiple times while I think hello, and then average those recordings to get a representative pattern.
You got it. And by doing this for various things, like saying yes, no, specific words, or even short phrases, the system builds up a collection of brain activity signatures, a kind of neural fingerprint, if you will, for each intention. What's interesting is that the patent includes examples of these normalized curves for different people, Joe, Steve, and Anita, saying yes and no. And you can clearly see that each person's yes pattern is different from their no pattern, and also different from the yes and no patterns of the other individuals. Really highlights the individuality of brain activity.
Like a unique fingerprint for each thought. Okay, so we have this collection of normalized brain activity patterns. How does this system then figure out what a person is trying to communicate in real time?
So that's where the real-time comparison comes in. The brain activity being monitored gets sent to the computer and compared against the library of stored normalized patterns. The system looks for a close match. what the patent calls a substantial match.
Okay, and if the computer finds a close enough match?
Well, if there's a match, the computer determines if the person is trying to communicate that specific word, phrase, or thought. So, using our previous example, if the incoming brain activity closely resembles Joe's normalized yes pattern, the system interprets that as Joe trying to say
It
yes.
sounds incredibly complex. Analyzing brain activity, which is very noisy and dynamic, must be a huge challenge.
Definitely. And the patent acknowledges that, suggesting that neural networks might be used within the computer system.
Neural networks, that's a type of AI that can learn, right?
Yeah, that's right. These neural networks could be trained to recognize specific brain activity patterns and classify them, even if the relationships in the data are complex. This could allow the system to interpret the brain signals and infer the intended communication, even learning new patterns over time as it gathers more data.
So the system could get better at reading someone's thoughts the more it interacts with them.
Exactly. And here's where it gets really interesting. The patent doesn't just stop at communication, it explores other potential applications too.
Oh, like what? Besides silent communication.
Well, one that really stands out is lie detection. The idea is that if someone deviates significantly from their established brain activity patterns when answering a question, it could indicate deception.
Wow, that's a controversial but fascinating application.
Yeah.
Anything else?
Yes. They also mention two-way communication. Imagine if both individuals had the necessary systems, they could have a silent conversation just by thinking. Their brain activity would be translated and understood by the other person's system.
No more language barriers.
Yeah.
Amazing. But the patent goes even further. It talks about this idea of brain node firing for control. Sounds like something out of a science fiction movie.
It does, doesn't it? This part shifts from interpreting brain activity to influencing it. The idea is to identify specific brain regions, or brain nodes, associated with things like appetite, mood, or even specific thoughts or communication abilities.
And how would they control these brain nodes remotely?
They propose using devices, maybe implanted under the scalp, that could be energized remotely. These devices would then stimulate the targeted brain nodes, potentially affecting things like hunger, thirst, anxiety, or depression. They even suggest replacing the sensors with these firing devices for a fully implantable system.
So you could potentially trigger specific feelings or influence behavior from a distance. That's a pretty huge concept to think about.
It is. The patent doesn't go deep into the implications, but the potential is mind-blowing.
Absolutely. Now let's get to some great questions we received from our listeners about this patent. The first one asks, how can brain activity analysis enable communication and control in remote satellite systems?
Right, so we've talked about the satellite as this relay station for long-distance communication. Brain activity is monitored at one location using sensors, then transmitted as a signal to the satellite. The satellite receives, amplifies, and redirects that signal to a receiver at a remote site. That's where the computer analyzes the data, comparing it to the individual's stored brain activity patterns. For control, signals from the computer could go back to the satellite and then to the individual's implanted device, which would stimulate specific brain nodes. So the satellite essentially enables a two-way flow of information monitoring brain activity and influencing the individual from a distance.
Makes sense. Another question here is, how do monitored brain data compare with stored data?
Great question. The comparison process is at the heart of this. The monitored brain activity is captured as waveforms or signals and sent to the computer. Then the computer uses advanced algorithms, maybe even neural networks, to compare that incoming data with the stored normalized brain activity patterns. These stored patterns represent the individual's brain activity associated with different thoughts or intentions. The system is looking for a very high degree of similarity, a substantial match, between the live brain activity and one of these stored patterns.
I see. We have another one. How does the invention enable communication between individuals?
Think of it as translating one person's brain activity into information another person can understand. The sender's brain activity, reflecting their thoughts or words, is monitored and transmitted. On the receiving end, the computer analyzes that activity, compares it to the sender's unique brain activity dictionary, and identifies the intended message. This message could then be presented in a way the receiver understands, like text on a screen or even spoken words. And remember, the patent suggests two-way communication is possible, too.
That's incredible. The next question asks, how is normalized brain information obtained?
Well, as we discussed, the patent talks about a process of repeated recordings. They would record an individual's brain activity multiple times while they are exposed to the same stimuli or trying to communicate the same thought or phrase. Then, these multiple recordings are processed to filter out noise and pinpoint the consistent patterns associated with that specific thought for that specific person. That way, you have a reliable baseline for each individual's brain activity.
So you're essentially creating a very precise and personalized brain activity map. And this one asks, what basic components make up the communication system?
According to the patent, the key components are sensors to detect brain activity, a transmitter to send the data wirelessly, a satellite for long-distance communication, a receiver to capture the signal, and a computer system to store and analyze the data, potentially using neural networks. And of course, you would also need the firing devices to stimulate specific brain nodes for the control aspect of the invention.
That covers the key elements. Our last question is, how is monitored brain activity transmitted remotely?
The patent talks about wireless transmission. The signal from the individual's transmitter could be sent via radio frequency to a local receiver, or, for long distance, it could be sent to a satellite. Then the satellite retransmits the signal down to a receiving antenna at the destination. The patent mentions both digital and analog approaches, where brain activity is represented as binary code or transmitted as raw brainwave signals.
This deep dive has been a fascinating journey. Even though this patent is from the late 1990s, the ideas it presents are still very advanced and incredibly thought-provoking.
Definitely. It really speaks to our ongoing fascination with understanding and harnessing the power of the brain for communication and beyond.
Let's recap. We've looked at this invention proposing communication and control through brain activity analysis. We covered the importance of personalized brain activity patterns, the role of computers and neural networks in interpreting these patterns, and the potential applications, from silent communication to influencing brain states, even across continents using satellites.
It's remarkable to think about the implications of this technology, even today.
It is. Thanks for joining us on this deep dive. We'll see you on the next one. Keep those minds curious.